Imagine this: Earth, a blue jewel floating in the vastness of space. Suddenly an asteroid hurtles toward our planet, growing larger and larger. Warning alarms blare as the danger becomes imminent. Imagine looking up at the night sky and seeing a massive asteroid on a collision course with Earth. It's not just a plot from a Hollywood movie. This is a real danger, and scientists around the world are working hard to make sure we're prepared for it. Today on Cosmic Chronicles, we're diving into planetary defense. What would we do if an asteroid was heading straight for us? What technology are scientists developing to stop this from becoming a catastrophe? And can we actually save the planet? Let's explore the science behind stopping an asteroid. Asteroids are remnants from the formation of the solar system over 4.5 billion years ago. They vary in size from small rocks to massive bodies several kilometers wide. While most of them peacefully orbit the sun, some are on a trajectory that brings them close to Earth. Throughout history, asteroids have impacted our planet, some with devastating consequences. The asteroid that wiped out the dinosaurs was around 10 kilometers wide, but even smaller asteroids like the one that exploded over Tunguska in 1908 can cause enormous destruction. Today, scientists are constantly tracking thousands of near-Earth objects, or NEOs asteroids, whose orbits bring them dangerously close to our planet. Organizations like NASA and the European Space Agency have set up dedicated teams and telescopes to monitor these objects, cataloging their size, speed, and distance from Earth. The key is early detection. The more warning we have, the better our chances of preventing a collision. But what if we discovered an asteroid on a direct collision course with Earth? What could we do to stop it? One of the most promising techniques is the kinetic impactor method. This approach involves slamming a spacecraft into an asteroid to nudge it off course. The idea is simple. A small change in an asteroid's trajectory over time could make it miss Earth completely. NASA's DART mission, which stands for Double Asteroid Redirection Test, is the first ever attempt to test this method on a real asteroid. In 2022, DART successfully collided with a small asteroid called Dimorphos, altering its orbit. While Dimorphos posed no threat to Earth, this test was a crucial step in proving that we can redirect an asteroid if we spot one early enough. The kinetic impactor method shows that planetary defense is not just a theory, it's something we can actually do. Another method that's often brought up, especially in movies, is the use of nuclear weapons. But don't imagine Bruce Willis flying into space with a bomb. In reality, scientists are exploring the possibility of detonating a nuclear device near an asteroid, not to blow it apart, but to give it a gentle push. The explosion would create a blast of energy, vaporizing part of the asteroid's surface. The vapor would act like a mini thruster, slowly pushing the asteroid off course. While this might sound extreme, nuclear deflection is considered a last resort option if we have very little time to respond and need to make a rapid change to an asteroid's path. But what if we had more time? Enter the gravity tractor, a more delicate but highly effective solution. In this method, a spacecraft would fly alongside an asteroid for months or even years. The spacecraft's gravity would slowly pull the asteroid, altering its trajectory just enough to miss Earth. The beauty of the gravity tractor method is its precision. It wouldn't involve any explosions or direct impact, but simply the slow, steady pull of gravity. However, this technique requires a long lead time. We'd need to detect the asteroid years in advance to make the gravity tractor approach viable. All these methods rely on one critical factor: early detection. That's why scientists are developing new systems to spot dangerous asteroids as soon as possible. Ground-based telescopes are key players, but future missions could involve space-based observatories specifically designed to detect near-Earth objects. Artificial intelligence is also playing a growing role. AI systems can analyze huge amounts of data in real time, identifying potential threats and calculating impact probabilities faster than ever before. This combination of advanced telescopes and AI could be the early warning system humanity needs to act before it's too late. International collaboration. Planetary defense isn't just a job for one country or one space agency, it's a global effort. After all, an asteroid impact would affect everyone. That's why space agencies from around the world are collaborating to share data and develop technologies that could protect our planet. The United Nations has even established the International Asteroid Warning Network, which coordinates global efforts to detect and track potentially hazardous asteroids. If we ever face a real asteroid threat, it will take international cooperation to stop it. What if we can't stop it? But what if we don't detect the asteroid in time? What if none of these methods work? If an asteroid impact is inevitable, the focus would shift from deflection to evacuation and damage mitigation. Evacuating areas in the projected impact zone could save millions of lives. But depending on the size of the asteroid, the impact could still cause devastating tsunamis, earthquakes, and even trigger global climate effects. That's why prevention is the best strategy, but being prepared for the worst is essential. The future of planetary defense. Looking forward, the future of planetary defense lies in constant vigilance. With advances in technology, new telescopes, AI systems, and international cooperation, we're getting closer to being fully prepared for any potential asteroid threats. Scientists are even exploring the idea of building space-based defense systems, satellites or spacecraft stationed in orbit ready to respond quickly to any incoming asteroid. It's not just about saving Earth from one asteroid, it's about building a defense system for generations to come, ensuring humanity's survival in a universe full of cosmic hazards. Asteroids may seem like distant threats, but they're a reminder that we live in a dynamic universe, one where planetary defense could mean the difference between catastrophe and survival. Thanks to cutting-edge science and the dedication of global teams, we're better prepared than ever to protect our planet. But as we explore the cosmos, it's essential to remain vigilant and continue improving our defenses. The future of Earth's safety lies in the stars. What do you think? Could we stop an asteroid in its tracks, or are we playing a dangerous game with space? Let me know in the comments, and don't forget to like and subscribe for more cosmic insights right here on Cosmic Chronicles. Until next time, stay curious and keep looking up.